In this video, we're going to do section 9.1, which is solving quadratic equations. And we started that the other day in class with the Pythagorean theorem problems. But we're going to review anyway how to solve some of these quadratic equations by factoring. Alright, so remember the first step in any factoring problem is to factor out the greatest common factor. So if I look at 5x squared plus 11x equals 0, I see there's a greatest common factor of x. So I'm going to factor out the x, and I'm going to end up with x times 5x plus 11 equals 0. And so then I'm going to set each of the factors equal to 0, so either x equals 0 or 5x plus 11 equals to 0. And then I need to solve each of these, so x equals 0 is one of the solutions. Then I subtract 11, so 5x is equal to negative 11. Then I divide by 5, so x is equal to negative 11 over 5. So there's two answers, or two solutions here. X equals 0 and x equals negative 11 over 5. Alright, so I hope that all of you are okay with that. And again, if you have any questions about this, feel free to email me or bring your questions to class. Alright, so let's look at another one. And this is number 2, 5t minus 6 equals t squared. So what I need to do in any quadratic equation is write it in the quadratic form or the standard form here. So I'm going to set it equal to 0 by subtracting the 5t. So negative 6 is equal to t squared minus 5t. Then add the 6 to get 0 is equal to t squared minus 5t plus 6. Then remember, when I'm doing these types of factoring problems, I have to find numbers that multiply to the n number of 6 and then add together to the middle number of negative 5. And I know that well, actually, wait a second. Do I know that? I don't know that. I'm sorry. I know that. Well, where did negative 1 times negative 6 is 6. Negative 2 times negative 3 is 6. 1 times 6 is 6. And 2 times 3 is 6. So then I have to add each set of numbers up and see which one will give me my negative 5. So let's see, what is this going to give me? Which one is it? I'm looking very carefully. I actually already passed it, if you didn't notice already, and it's negative 2 and negative 3. So I'm going to have t minus 2 and t minus 3. Then set each of the factors equal to 0 here. So then when I'm going to add the 2 to get t equals 2, and then add the 3 to get t equals 3. So there are my two answers, t equals 2 or t equals 3. Alright, let's try another one. And number 3 is a little bit more difficult, but I'm sure that you guys will remember this. Now, first of all, remember I have to make sure to factor out any greatest common factor, but I don't see any between the 3x squared, the 10x, and the negative 8. So remember, this is the method, the slide and divide method that I talked about in class, because I have a number that's not a 1 in front of the x squared term here. So I'm going to multiply the 3 and the negative 8. So x squared plus 10x minus 24 is 0. And then I need to find numbers that multiply to negative 24 and add to give me the 10. So let's see, what is that going to be? That looks like a 12 times a negative 2 is negative 24. And a 12 plus a negative 2 is a 10. So I have x plus 12, x minus 2 is 0. Then I do my dividing. So I divide by this 3 that I slid over here to begin with, and then I simplify the fractions, so x plus 4, and then 2/3 does not simplify, and then I bring the 3 back in front, so I have x plus 4 times 3x minus 2 is 0. And then I set each factor equal to 0. X plus 4 equals 0, and 3x minus 2 equals 0. Subtract the 4, so x is equal to negative 4. Add the 2, so 3x is equal to 2, and then divide by 3, so x is equal to 2 over 3. Kaboom! Alright, you have your two solutions. X equals negative 4, and let's see, x equals 2/3. Again, I know none of you probably are really enjoying this very much, but feel free to send me any questions or bring them to the next class. Alright, let's go on to number 4 here. Y minus 7, y plus 5 equals negative 20. Now this one is a little bit different. We can't just set this equal to negative 20. We're going to have to use the FOIL method here whenever we see two sets of parentheses like this. So y times y is y squared, y times 5 is 5y, negative 7 times y is negative 7y, and negative 7 times 5 is negative 35 is equal to negative 20. I'm going to combine the like terms to get y squared minus 2y minus 35 is equal to negative 20. Then add the 20 to set this equal to 0. So y squared minus 2y minus 15 is equal to 0. Then I factor this like I have done in some of the previous problems. So I end up with y minus 5y plus 3 equals 0. Again, take a second to make sure that that makes sense to you, because you are the ones who are going to have to do this again on a quiz or a test or just walking down the street in life one day, right? Alright, so now solve each of these equations here. Y minus 5 equals 0 and y plus 3 equals 0. So I'm going to add the 5 to get y equals 5, and I'm going to subtract the 3 to get y is equal to negative 3. Alright, so there are my two solutions again. Alright, so now I'm going to go on to the next page. Hopefully, if that didn't all make sense, you will either ask or you will make sure to rewind and watch it again, or go seek help in the math lab or any type of thing like that. Alright, so this next method is called solving by the square root method or by root extraction. So this one, just remember that we're going to have to put a plus or minus whenever we take the square root. Alright, so that's pretty much it. So if I have u squared is equal to 24, and I take the square root on each side to solve for u, I have u is equal to plus or minus the square root of 24. Done. Alright, 5x squared minus 49 equals 0. I want to solve for this x squared right here, so I'm going to add 49. So 5x squared is equal to 49. Then I'm going to divide by 5. So x squared is equal to 49 over 5. And then I'm going to take the square root. That means that x will equal plus or minus the square root of 49 over 5. But just to make it a little bit easier on all of you, I know that this is the square root of 49 over the square root of 5, and that the square root of 49 is 7. So this actually looks a little bit better to take the square root of 49, since it's a perfect square and I know what it is. Alright, again, maybe in one of your math classes you were told to do a little bit more than that, but I'm not going to require that. Alright, so let's move on to excuse me, example 3. So here is example 3. So quantity x plus 3 squared minus 7 equals 0. I still want to solve for this x right here. So I'm going to actually add the 7, then take the square root. So I have x plus 3 is equal to plus or minus the square root of 7. Then I need to subtract the 3, but because of this plus or minus here, I'm actually going to write it in front of the plus or minus. Although it would have been correct to write negative, plus or minus negative, plus or minus the square root of 7 minus 3. Well, that's okay, but negative 3 plus or minus the square root of 7 is better. Alright, you can see a couple of reasons why, and one of them being specifically that someone might accidentally write that negative 3 under the square root when they shouldn't. Alright, number 4, 9n squared plus 121 is equal to 0. I'm going to solve for n, so take the 121 to the other sides, or subtract the 121. So we have 9n squared is negative 121. Then I'm going to take these, well actually, you don't have to take the square root yet. You can divide by the 9, so n squared is negative 121 over 9. And then I'm going to take the square root. Now, I haven't had a negative number under the square root before. Remember that, please. But I have n is equal to plus or minus, and then I have the square root of negative 121 over square root of 9. I know the square root of 121 is 11, so if I make that 121 negative, it's actually just going to be 11i, meaning that it is an imaginary number. And then I also know the square root of 9 is 3. So I have n is equal to plus or minus 11i over 3. Meaning that we have an imaginary answer, or something that is just real and fake. Alright. So, hopefully everyone is doing okay so far, because I'm going to move on to the third method, which is probably the hardest one. So, give me a second. Alright, so this method is going to be the hardest one that we've ever did in this entire class. And it is called completing the square. Alright, so let's take a look at how we're going to do completing the square. And you're sort of going to have to believe me that this works, or else you can read the entire proof that I have that takes up half of your page 138. Alright, so we have x squared plus 6x plus 5 is equal to 0. Make sure that this number in front of x squared, the a, is always equal to 1, and that b is equal to 6, and c is equal to 5 before you start. So you want to make sure this a is always equal to 1 before you start, and then label the b and the c as well. Alright, so here's what we're going to do. We're always going to subtract the c to the other side. So x squared plus 6x equals negative 5. Then we're going to add a half of b over a squared to each side. And that is just something that you are going to have to remember that you're going to add to each side. Alright, so now I know that b was 6, so I'm going to substitute that in. And a was 1. And then over here I have b is 6 and a is 1. Then I'm going to simplify the insides of these parentheses here and here. So 1 times 6 is 6, and 2 times 1 is 2, so 6 over 2 is actually 3. So I'm just going to write it as 3 squared. I think that that is something that all of you can remember. Okay. So then I have x squared plus 6x, and then 3 squared is 9, is equal to negative 3 plus 9. And then negative 5 plus 9. And then negative 5 plus 9 is actually equal to 4. Then I can factor this side. So I know that 3 times 3 is 9, and 3 plus 3 is 6, so I'm going to make this side into x plus 3 equals to 4. Then I know x plus 3 times x plus 3 is x plus 3 squared equals to 4. Then I'm going to combine the factoring that I just did here sort of with the square root method and take the square root. So I know x plus 3 is equal to plus or minus the square root of 4, or plus or minus 2. Then I'm going to subtract the 3 from each side, and remember I write the number I subtracted in front of the plus or minus sign, so negative 3 plus or minus 2. And that gives me two answers. One of them is negative 3 plus 2, and one of them is negative 3 minus 2. So my answers are negative 1 or negative 5. If you don't believe me that this works, you can check, because remember our original equation was x squared plus 6x plus 5 is equal to 0. And let's substitute in the negative 1. So what do I get? 1 minus 6 plus 5. Well, that's negative 5 plus 5, 0. Kaboom, that one checked out. And if I substitute in the negative 5, I usually, again, wouldn't check these, but I just want you to make sure for yourself that you understand that this completing the square method is going to give you something that is correct, even though it seems like a lot of work. Because I know it's a lot of work, but I know all of you are up for the challenge. Alright, right, Matt? I know you are. Alright, so now let's look at page 139. X squared minus 11x plus 30 is equal to 0. Again, I want to make sure this a, or the number in front of x squared, is 1. And then in this case, b is negative 11 and c is 30. I always want to make sure to subtract the c first, so I have x squared minus 11x is equal to negative 30. Then I'm going to do the same thing I did before and add a half of b over a squared to each side. Excuse me. Okay, so a half of b over a squared to each side. So now I have x squared minus 11x plus a half times negative 11 over 1 squared. And this one is going to be a fraction, and I know this makes it even more exciting. Alright, at least it is for me. Alright, so now I have x squared minus 11x plus negative 11 over 2 squared equals negative 30 plus negative 11 over 2 squared. Now, I'm going to use a little shortcut to not have to deal with this fraction and just tell you that whatever number is here is the number that is going to be the number that you use to factor. So in this case it was negative, so this is going to be negative. Alright, that's a shortcut. Please use it, especially when you're working with fractions. It would have even worked in the last case. Alright, but I feel like with fractions it's even more imperative that you don't mess up the fractions. Then I have negative 30, and I know negative 11 squared is 121, and 2 squared is 4, so I have 121 over 4. Then I need a common denominator, so I have to write that 30 over 1 and multiply by 4 over 4. So this side on the left is a perfect square, and this side on the right, negative 30 times 40 is negative 120. 1 times 4 is 4. And then I have negative 120 plus 121 is 1 over 4. Now I'm ready to do the square root method. So x minus 11 over 2 is plus or minus square root of 1 over 4, but square root of 1 is 1, square root of 4 is 2. Then I add the 11 over 2. Remember, I add it in front of the plus or minus sign. So I have 11 over 2 plus or minus 1 over 2. And that still, again, gives me two answers. It gives me a 12 over 2, which is a 6, and it gives me a, 10 over 2, which is a 5. I hope that all of you are enjoying this. Again, if you feel like I'm going too fast, you can always rewind me, because I know that all of you want to hear me over and over again, right? Or else you can stop and say that this is one that you want to go over in class, or whatever you feel is best for you to understand it. Alright, so let's look at number 3. So 7x plus 1 over 5 is equal to negative x squared. So in this problem, I see that I have a fraction, so I'm just going to multiply by 5 on each side to get rid of the fraction. Then I'm going to add the 5x squared to each side to set this equation equal to 0. Now I see a problem. My number in front of x squared is not a 1. But this is pretty easy to fix. Just divide everything by 5. So I have x squared plus 7 over 5x plus 1 over 5 is equal to 0. Now the a I'm working with is 1. My b is 7 over 5, and my c is 1/5. So I need to start by subtracting the c, or the 1/5, just like I have in all of the problems up until now. Then, if you remember what I did next, I added the 1/2 and then b over a squared to each side. I know this is a lot, but you guys are strong. You will endure completing the square. Right, so this is x squared plus 7 over 5x plus a half times 7 over 5 over the 1, but that's really just 7 over 5, equals to negative 1 over 5 plus a half times 7 over 5 over 1 squared. So now let's simplify the inside of the parentheses like we have been. And this is 7 over 10 squared. And this is 7 over 10 squared. Now, let's factor this. And again, remember when we were dealing with the fractions before, I said to just use this number to factor, and it's positive 7 over 10. Now on this side, I'm going to actually multiply the 7 out, and so 7 times 7 is 49, and the 10 out, so 10 times 10 is 100. Then I need to find a common denominator, which looks like it's 100, so I'm going to multiply by 20. So I have x plus 7 over 10 squared is equal to 20 over 100 plus 49 over 100. And then I'm going to simplify. So 20 plus 49 is 69 over 100. Now I'm ready for the square root method. So x plus 7 over 10 is equal to square root of 69 over the square root of 100, which is 10, and then we have to remember plus or minus. Then I'm going to subtract the 7 over 10, but remember to put that in front of the plus or minus sign. And then, because this is a non-perfect square under the square root here, I am just going to leave the answer like this. You could get a decimal if you wanted to, but there is no need to do that. Alright, so that is it for example 3. Let's see, I think that is the end of the section, because there are some that you can try on your own if you would like. But in the next section, we're just going to move on to something a little bit different, the quadratic formula. Alright, so I hope that you enjoyed section 9.1 as much as you can, and if you have any questions, again, feel free to bring them to class.